Thank you so much, Carsten, for the introduction. And yeah, I'm Matthias, very happy to be here and very happy to be joined by Marika. And as you already heard, one of us is more of a Java developer, one more of a JavaScript developer. So regardless whether you're a Java or JavaScript developer, there's content for both of you in this session. And yeah, we will split that a little bit accordingly to what our expertise is. Towards what we're going to talk about in this session. So I think we are all aware that integration is one of the concepts and one of the key points today, right? We no longer build monoliths and have everything in one deployment, right? We have a lot of microservices that are deployed in the cloud, a lot of systems, a lot of services. And this session is all about, if we have a CAP application, how do we connect to these, right? How do we connect our backend application to other systems, to other services, so that we can make most use of what these services and systems have to offer, whether those are LOB systems, whether those are other microservices, right? Whether it's third-party applications, BTP services. So anything like that basically is like about service consumption, and that is what we want to talk about today. And also what we mainly focus on in the SAP Cloud SDK, which Marika will introduce a little bit more about.
SAP Cloud SDK is the basis of CAP for service consumption. So CAP uses the SAP Cloud SDK for service consumption. Who has been in the session this morning about the Cloud SDK actually? Yay! Yeah, I've seen a lot of people there as well. Anyways, I wanted to give you a short overview of what the SAP Cloud SDK is, because we will not talk or show everything that we have mentioned here, but a few things of those. So SAP Cloud SDK is all about consumption, as I just said, and especially it helps you with understanding and using SAP BTP connectivity services like the SAP BTP destination service and also the on-premise connectivity service. So it's kind of working out of the box. You will see this later in code. The SAP Cloud SDK is tenant and user aware out of the box, so you don't need to take care of user isolation or tenant isolation. You can change it, you can adjust it, but generally everything you do is tenant safe, let's say. This also is true for both of the SDKs, so Java and JavaScript as well. We have resilience, so resilience is built in. It's a bit different between Java and JavaScript. You will see the differences later. And also the way it integrates with CAP. This is due to many reasons, and you will see some of those later. And then there's one more thing that is quite unrelated to CAP, which are the generated OData and OpenAPI clients. Those are clients that you can use in your code in your native language, basically, so Java or JavaScript. And Matthias will tell us a bit more.
Thank you so much, Marika. Right. The rest of the session, basically, just to give you a brief overview, will mostly be coding, right, and demoing. But just so that we have an idea what we're gonna do, right? We're gonna connect like a simple CAP application to a remote OData service and just see how this exactly works, how CAP and Cloud SDK sort of work together to get that done, right? And how you can start there and add stuff like resilience on top, right, to make sure that the connection you just made to the remote service doesn't take down your application once the remote service is maybe temporarily offline or there's some problem, right, that causes calls to take a long time. That your application performance doesn't degrade because of that. Right, so let's get started. And as I said, we have both Java and JavaScript variants, but we're gonna get started on the Java variant. So what I want to introduce first is a small use case that we've built just for this small demo. We have a very simple Java, a very simple CAP application that serves a small front end with like to-dos. But the caveat here is, or the important thing is, these to-dos are not coming from our backend. They are coming from some remote service, right? Somewhere there's a to-do service running that owns these to-dos, right? We don't have any control over that, but we can use it. It's an OData service that's deployed somewhere. It doesn't really matter where. It could be S4HANA, could be an LOB system or whatever, right? Could be your own third-party application or microservice. And we want to do a little bit of that with the to-dos. We want to have like a smart AI generated suggestion to add new to-dos to our to-do list, right? So we want to have a small implementation in the backend that does this. And here, and I have to quickly jump back to my presenter mode to make it bigger. Here we go. All right, so that you can actually read what we have. So we have here a small CAP application, and I've already added a handler here. And if I can just also show the project, here we go. You can see it's just the typical Java CAP Java application, right? We have our main application here, and currently I'm in the to-do controller, right? This is then the to-do suggestion that we want to generate, and now the question is, how can I here go to my to-do service that's running remotely, right? How can I get that done? And CAP has this very nice feature called remote services, right? That allows me to import any OData specification from anywhere, right? From API Business, Accelerator Hub, I think it's called right now, or from other CAP services, right? Or from a BTP service. I can import that into my project, right? And this is what I have done here already. And there's a command that's called CDS import. If you run this, it will basically take an EDMX file and add it to your project and add a small entry here in the package JSON that looks like this. In this case, we can see this to-do service here is like an external OData v4 service, right, that is running somewhere. And we've added this to our project with CDS import. As I said, I already did this, right? So I have a directory here now, external, and in there I will find the specification, the metadata of this remote service. And what this allows me to do is that when I run Maven compile, basically, I will get the generated sources here for this remote service in my Java application, right? And I can use it. So let's implement a small handler here that returns a list of to-dos, right, from this remote service. As you can see right now, it's just collections empty list, right, because we haven't done it yet. But this is really, really easy to do. We can just do add autowired, add qualifier, and here this one is actually not exactly right. We have to do to-do service.cds name. And then this can be like private CQN service. This basically tells CAP, hey, I want to use this remote service that I just imported, right? So this gives me an API basically that I can use to run queries against. And when I use this here, you will already see Copilot suggesting some to run some queries. This here is a bit too rudimentary for me. I could just select basically everything from to do and just run this. But I think I would rather prefer to at least limit this a bit by like the top 10 to-dos should be enough. If you have more than to-dos, then you have some problem. Or let me call this query maybe. Okay, and then I can just do service.run of query. And this will give me a result. And I think what I can do here actually directly is I do as list of correct one dot class. And then I can just return this. Right now it tells me I could inline this. Yeah, fine. Don't want to do that. Maybe I actually do log.info. And also log at least the size, how many to-dos I found. Okay, so this is basically all the code you need, right? You have a CQN select statement, and the remote services feature from CAP basically knows, okay, this to-do service here is not my database, but it's an OData service running somewhere, and it will transform this to an OData query basically under the hood and then send it. Now the question is still, okay, we can write this code, but where is it sending it? right? So far we have told CAP what is the metadata of this service that we want to reach. Okay, so we know the data we can send and receive. That makes sense, right? We can write this in code. We have written the code and specified the query we want to run, but we still have to tell it, okay, where is this actually running and how do I authenticate? And this is done by giving CAP a destination. In Java, we can actually do this in the application YAML, for example. There's this entry CDS, remote services. And here we have the to-do service, right? We imported this in our package.json, and we can now specify, okay, we want to use a destination with name to-do service. And we want to have this path, and it's an OData before service, actually. And this destination we have to create somewhere, right? So typically, you would create this in your BTP cockpit. Or if you have a multi-tenant SaaS application, your customers, right, your tenant accounts can define their destination. And then depending on which tenant will use this feature, the destination from the tenant will be used. In our case here, we've actually defined a destination in the destination service and also one locally just for testing, but I can maybe briefly just show the one on the, or I cannot because I get logged out. Yeah, but so in the BTP cockpit, you can define a destination, or you define one locally now here for local debugging. Right, I would say we just run this change that we just did. I can go back here. I think just rerunning this should be fine, but maybe I just started in debugging mode actually. Then we can see a few breakpoints just to see how this actually works. Oh, in presenter mode here, this is not so easy to read the logs. That's okay. So the thing started, and we go here, crash this, make sure we use the Java backend. Okay, and our front end now queried our local server here, and if I jump ahead a bit, we can see what this will actually do. Right now, yeah, okay, doesn't matter. I've set a breakpoint on the query, right? And this is now during query execution. And this here is then basically a new OData request. So as I said, the CQN is getting translated to OData. And as you can see, this is a Cloud SDK class, right? So this is the point in Java where the Cloud SDK comes in. All of the connectivity handling, all of the destination handling, basically the Cloud SDK takes care of and prepares all of that, right? And then CAP basically formulates a Cloud SDK-based OData request and then executes this, right? So we can see here exactly the query that's being built up. And if I run this, in the end, it should return some data. So it said here, okay, I found my 5 to-dos, right? And in the front end, they would be displayed. And actually here, this is currently our AI logic. We suggested to write a CAP application and then finish the other to-dos, which makes sense, I think. Okay, so this is basically a very brief dive into how does this work, right? We just define a CQN service that we import via CDS import. We import the metadata into our project, then we have all of the generated classes that allow us to write the CQN query. And then we give a destination, and then under the hood, CAP and Cloud SDK execute this using the current tenant, using all of the connectivity logic on BTP to actually execute the request, right, and return us some data. Okay. So far, that is what I wanted to kick it off with on the Java side. And I would give it over to Marika to show you how this looks on JavaScript.
Sure. So basically what I will show you now is the same thing in JavaScript, only that I will go into a bit more details on what is happening under the hood. So this is the JavaScript code. So this is the generate to-do suggestion function that we have seen in Java as well. Yeah, Java is a bit more verbose. In JavaScript, it's quite short. And I have not used the CQL. I always forget which one is which. but instead I'm actually using the server service.read function, which basically is the same thing as the select in CAP. I need to enable my breakpoints, and then let's go to the application. I'll just reload. Reloading is a different. How do I reload here? It works. Okay. And now it already stops. So it stops at generating the to-do suggestion, because on loading the application, it generates a to-do suggestion. And then it first gets all to-dos to do some AI magic on top of it later on. So let's go into that. Here we connect to the to-do service, same way as we've seen in Java. But now let's take a look at what actually happens when reading the data. So this is still part of CAP. So this is basically the entry point of CAP to the Cloud SDK. CAP calls the execute HTTP request with origin function. There's another one which is called execute HTTP request, which is more suitable for non-library users. So probably most of you sitting here. But it does a very similar thing. The only difference is that we kind of make a difference on where headers come from and so on. This is more relevant for if you're kind of also creating a library. The destination is still just the destination name. So it's basically just the information that we want to have a destination that is called to-do service. We have a request configuration. This currently contains the URL to the service. This is what CAP gives us. Would you have a more complex query, like with selects and filters and so on? This is in CAP where it would already be resolved. So what CAP gives the SDK basically is the prepared OData request without connectivity information. So what we see here is really just the destination name and the request without connectivity information. But now let's go inside that. So if I also go across a bit to the next step, right before sending the request, so the SAP Cloud SDK for JavaScript uses Axios to execute requests. This is the execution. So this is the JavaScript code that is generated. The JavaScript SDK is actually written in TypeScript, and this is the transpiled code, but I think it's readable enough. We have the request, and here you can see that we already have a base URL. So we already have the base URL, and this came from our destination. So the destination, in this case, you can see it's localhost, is in development mode. It's an environment variable, but generally it would also read that from the destination service, as Matthias already described. So here you can see this is basically the step where you would get all authentication information and everything that you need to execute a request. So yeah, let's do that. Now you can see that it actually worked. So we have a new suggestion. Okay, but generally I get asked a lot, what is the difference between CAP and Java and the SDK? So either Java or JavaScript, doesn't matter. I always say the main difference is that the SDK is actually all about consumption, which is just a tiny part of CAP, right? But there are a few more differences. I'd say the main difference is, first of all, the fact that the SDK basically can be executed with any framework, so it doesn't matter, it's framework agnostic. It's just a library that you can use in any framework, same as CAP is using that in their framework, right? And the second thing is that it is basically, so we have the virtual data model, as some people call it, or the generated libraries that I will show you in a second. The generated libraries are kind of unrelated to CAP. And in most cases, you will not need to use it with CAP together because you have the query language from CAP. However, sometimes there are cases where there might be features that that don't work with CAP yet, or maybe you just like the structure more, I don't know. But I want to show you one of those cases. For example, if so we have these requests, but weekend is coming up and there are too many and I don't want to do them. Therefore, I might want to delete all of them, but I don't want to go to my server every time and just delete each of them one by one. I want to send them in one request. And therefore, I will show you the batch feature. So with that batch feature, you can basically see how you would use the SAP Cloud SDK generated client for OData. So if you have been in the session this morning, you might know that that we have there is what the generated client looks like. So basically, it's a set of libraries I already a set of files. I already pre-generated that because I don't want to do much action here. I just want to show you the code. So this is kind of for our to-do API, the to-do server. That's the generated client that you can now use in your code. And I'm doing that. I have a function that is called quit. I want to quit for the weekend. And in this quit function, I just delete all of the requests in one. So here I go. I connect to the to-do service and get the destination name from this service. So I get this information from CAP. There might be different ways to get this data. This is just one example. I get all to-dos that I already have. And for those to-dos, I create a request. And I do this by first retrieving the ID of each to-do. That's the ID. And this feature here is, if you know JavaScript, this is called destructuring. So you're basically accessing the ID. That's all I need for deleting an entity. I use the to-do API, which is, now I should probably go into a bit detail here, which is the API of the service for to-do. So each service or many services have more than one APIs in them. If you think of the business partner service, which is used in many SAP examples, so I hope that most of you know it, you will find the business partner entity in there. You will find the customer, the supplier, things like that, and all of those have their own API. And this is how it's modeled in the JavaScript SDK as well. Then you build a request, and then so this is just a builder that gives you different functions to build requests. And here we use the delete, so we just delete the ID. We do not execute this request, so it's really just a collection of requests. So this, you can see, okay, you cannot see, it's a list, basically just a list of requests. Nothing is done yet, so it's just a list. And now we want to execute that. So to execute it, there is the change set function, which comes from the SDK. You can wrap all those requests into one change set. This is what you need for batch requests in general. Once it's wrapped, you execute or you wrap this into a batch. In batch, you can basically combine multiple change sets. You can combine multiple change sets together with read requests as well. So yeah, theoretically, I could add new requests right behind here. In CAP, it is important to also use this feature, which so this basically just describes how the batch request will look like. So maybe a few words about batch. Batch basically means that you serialize your request into a string where you basically have the URL, the HTTP method, the data, the query parameters, and everything you use, and some more information, headers, and so on. Everything written down into a string for each request, and then merged together into one body of one request. And this basically decides or shows you or explains how to serialize the URL of each entity. This is relevant in OData. All three versions should be possible. So the three versions are: you have an absolute URL, you have a sub path, so really just behind the entity, or you have the whole path until like in the service. All three should work, but nobody does that. So each OData implementation will be different. And here in CAP, that's the one that you will use. And then the last step, that's the same thing that we saw with Matthias, I think. You execute and then you pass the destination name. So that's also what we saw in the, because we didn't see this with Matthias, we saw it in the code that the CAP service used, right? So what CAP does internally is basically the same syntax here. So that's the destination that we're using here. So what we will see here, it's just going to be the to-do service that we've seen before. I will disable the debug mode because now I just want to show you that it works. So I've had enough. Let's start the weekend. Okay, and yay, we deleted 5 to-dos, and that's what we get. And you can recreate the server on your own, right? You have to restart it. Now Matthias will show you something very similar in Java.
Exactly. Thank you, Marika. Right. So what we've seen is that we have multiple options, right? And that CAP builds on Cloud SDK. We can just write CQN if we want to. If for whatever reason writing CQN doesn't work, or we don't want to do it, or we are in a project outside of CAP, or whatever reason you have, right? You always have the option to also use the Cloud SDK directly, as it's basically just lower down the stack, right? And even if you have non-OData requests, right, you can just use the Cloud SDK connectivity. So just to give you an example, right, how it looks in Java, if you wanted to build a batch in Java, you could just do service.batch, right? And then you build a bunch of requests, add them to the batch, and then just send it, right, execute the batch. That's basically the same code as it would look in Java if you wanted to. But the main takeaway here really is like Cloud SDK can do the connectivity if you want to connect to anything via like the BTP connectivity services, right? You can already use Cloud SDK. For OData, you have the option to use the OData APIs of Cloud SDK, or even above to use the CAP CQN APIs, basically on the highest level of the stack. Right? Okay. But there is more stuff. And as I mentioned, one thing that we probably want to do when connecting to remote services is to make the connections resilient. And especially in Java, this is relatively easy with the Cloud SDK. What you can do is you can just take a resilience or build a resilience configuration. Let's call this, for example, just a remote service. We just give it an identifier. And let's just call this config like this, and execute any code with it, right? You can do resilience decorator, execute. And in this case, what we want to do is execute our run here, for example. So let's actually say here, this is our code we want to run in with our resilience config, and give config. Yeah. And then this is our result. Just to make this readable actually on the screen, let me do this. Okay, so what will this do, right? So we just changed the service.run into a execute service supplier with this config, right? This config basically, we give you a default resilience config with some nice patterns that are usually useful, right? And you can see actually what you get here. So for example, by default, if we configure nothing and just take the default config, we get a 10-second timeout. We will get a circuit breaker enabled, the bulkhead enabled, and caching and retries disabled. And actually, there's even a rate limiter included here that's also disabled by default. And of course, we can configure that, right? But like this is already an easy starting point. If you are not too sure what you need, right, this is relatively safe to apply to more or less anything, right? You will not do something completely bad. With retries, for example, you need to be a bit more cautious, right? You need to understand, okay, what happens, for example, if a server receives my request twice, right? Will this be still okay, or will I mess something up, right? So for a read request, for example, retrying is pretty safe, right? But for if you create something, you want to think about if retrying is a good idea or not. Same with caching, of course, right? Not the cache doesn't make always sense, or rate limit. Right. If you, but just to show a little bit of what options you have, you could also say empty. I don't want to have anything by default, right? And I just add individual things. For example, I only want a retry, right? And you could build a retry configuration. For example, you could say I want a maximum of 5 attempts, and I want to wait a duration of, let's say, 10 seconds in between individual requests. And I said, oh wait, this is not a string. Retry, for example, and then I can say, okay, I just want a resilience behavior where I retry. I try once, I retry 4 times, right? So a total of 5, and with 10 seconds in between, right? And this would do it, basically. The cool thing here is that this works with more or less any code, right? So you can literally put anything here. However, this also comes a little bit of the drawback that there's no magic happening in terms of, like, for example, HTTP requests, right? So the resilience in the Java does not automatically know, okay, you got a 401 and this will not be retried, but a 500 would be retried. You can configure this, right? You can say, I want to retry these exceptions, but others not. This is, you can configure this, but it's not like magically by default. Again, because you can use this resilience for anything, not only for HTTP requests, right? So yeah, that's just the reason for that. That's a little bit different in JavaScript, and Marika can tell you more about it in a moment. There's just one more thing I want to highlight here. I don't want to demo it right now because we didn't set up the demo application to show that. But so, I mean, this functionality is also provided by some of the standard or common Java libraries, right? We ourselves use a Java library to implement this under the hood, right? So this resilience here from Cloud SDK is backed internally by Resilience4j. So what does the Cloud SDK here actually add? And the interesting thing that it does is the isolation mode. By default, you get a tenant optional isolation, meaning that if a tenant is defined, these resilience patterns will be applied per tenant, right? You can also configure tenant and user isolation if you want to, for example. You can also enforce that a tenant must be there. If a tenant is not there, you get an exception. This is useful for some of the resilience patterns more than others. It depends which pattern exactly, right? But let's take, for example, the circuit breaker, which will stop requests if there were too many failures, right? What you don't want is that one tenant has misconfigured their system, right? They have a bunch of failures, and then your circuit breaker kicks in for all tenants and blocks all tenant requests, right? So that's why if you, I mean, the default here is, I think, isolation mode dot tenant optional. This is the default, right? Meaning that if a tenant is there in your user info object from CAP, the Cloud SDK automatically recognizes the tenant object from CAP or the user info object, right? And will take that tenant ID and will account for that in the patterns where it matters, right? In other patterns, it doesn't matter. For timeout, for example, right? There's no relationship. You just time out the request, right? Nothing really happens in terms of different tenants. But if you have a bulkhead, if you have a rate limit, if you have a circuit breaker, all of those have some state, right? And where you want to make sure, do you need tenant isolation or not, right? And so you can configure this here. So you can also say just none, for example, if your remote service has no dependency at all to any tenants, right? You would choose non-isolation and then you're good to go. One small little thing that's also specific for Java that this also does that seems minor, but is difficult to implement yourself if you need to do it yourself, is that for the timeout, if you have a timeout, in Java, this is implemented with multiple threads. And some libraries, including Cloud SDK and CAP, use thread locals. If you just spawn a new thread, this is lost, right? So if you just spawn a new thread, your user info object is gone, basically. And the Cloud SDK here automatically passes on the stuff, right? Both the Cloud SDK context, the CAP context, also from security library, if you're using that, is also passed on. And it's also quite easy to register your own thread local to be passed on. This is sort of a specialty of Java, right? That with the Java threading model and thread locals, that those can get lost. But yeah, the Cloud SDK will basically take care of that for you and pass this information on. Right, this is what I wanted to show in terms of resilience. I don't now have a demo set up to show some failures or anything, but I mean, we could, for example, just enable the time limiter and just hit a breakpoint and then just wait 5 seconds and then continue, right? Then the timeout would kick in. But yeah, I think you can all imagine how this would actually run. Yeah, and with that, I would give it over to you for the resilience in JavaScript.
Yes. So resilience in JavaScript, as Matthias already mentioned, is a bit different. So the concept is so far different that here you can use the resilience configuration on everything, and therefore you can also use it on CAP requests. With JavaScript, this is currently not yet possible, but as far as I know, CAP will actually build that in at some point in time. It's planned, but I don't know for when. Therefore, as of today, it's not possible to use the resilience with the SAP Cloud SDK for JavaScript with CAP out of the box yet, right? However, what I wanted to mention that, so Matthias kind of explained that the fact that resilience is wrapped around everything makes it a bit different from what happens in JavaScript. In JavaScript, resilience is only wrapped around your requests or around everything you do to achieve everything that you need to get to your request, basically. So the concept that we use is middlewares to achieve that. And I now realize that I have never tried to type this on your computer. Let's see if this works. So basically what you would do is add a middleware. And there are different kinds of middlewares that you can use for resilience. So the three things or the three types of resilience that the SAP Cloud SDK for JavaScript supports are timeouts, retries, and circuit breakers. We do not support rate limiting and bulkhead. And for now, it's also not planned. That's why we are also not doing the thing that Matthias explained about splitting for tenants. The reason is that we actually do have the information whether this was a 401 or not, and retries, for example, will not be applied to 401 requests, and they will also not be treated as circuit breaker issues. But generally, what you would do, so it's really quite simple. To enable resilience is import the resilience function from the resilience package. Call it, that's it. You can also configure that. So as I just mentioned, there are retries and so on. So you can Geschäfteklammern. You can add configuration here, for example, by adding retry. So the number of retries, for example, 3. So yeah, that's what I just wanted to show you about that. And I hand it over for the outlook to Matthias.
Thank you, Marika. Always astonishing how short JavaScript can be. Right. I think we showed a bunch of code and a bunch of working stuff. We want to share a bit more. So, I mean, this was now quite a lot of content, right? And even though maybe the CQN and the resilience code itself was quite short, still this was a lot of stuff. So you can find all of this with examples, with documentation, right, on the CAP remote services documentation for all of the writing CQN, right, importing the definitions, right, and configuring all of that. If you are curious about more details on the Cloud SDK connectivity, you can also head over there or check out the documentation on the resilience part of the Cloud SDK, right? And of course, you can always contact us. The JavaScript SDK is open source. The Java SDK is going there soon, TM. And there's also now after this expert session in dedicated time at the expert pods, basically, where we too, but also some experts from CAP will hang around to talk about anything related to outbound communication and to destinations and remote services in general. So feel free. I mean, we have maybe 1 minute, I think, for questions, but yeah, we can discuss also longer after that. So don't hesitate to reach out. And with that, I have a thank you slide here and then the Q&A slide here.
In the room wants to, did you cough into that microphone? No, just kidding. If anyone in the room has a question, you can have the microphone as well. Or are you all going into the in-fight discussion in the expert session and expert booth now? No questions right now in the room? 1, 2, 3. Then thank you, Matthias and Marika, and they'll probably all come over now.